In this example, we're given a tri-substituted benzene derivative that has a bromine, a butyl chain, and a nitro group, and we're asked to start specifically from benzene. Give it a try and see what you can do. So thinking about the groups that are in our product, we have an ortho-para director with the alkyl group. The bromine is also an ortho-para director. The nitro is the only meta director. And notice that the nitro is actually all three groups are meta to each other, which means we could add the nitro first and then get one or the other of the second groups on. But as soon as we added one of those ortho-para directors, it would take precedent over the nitro, and our next group would end up somewhere other than where we wanted it. So to get around this, we're also thinking about how we would get around the potential problem of a carbocation rearrangement with alkylation, which is that we could acylate first. So if we do that, start with benzene and add our carboxylic acid chloride with aluminum trichloride, that will give us a ketone, which gets that carbon chain on there cleanly and is also a meta director. Now that means we're encouraging the next substituent to go where the bromine is, or where we want the bromine to be, as well as where we want the nitro to be. Now if we put the bromine on next, it's going to then direct the nitro, ortho, or para to it, and we don't want to do that. So the best option to do next would be to nitrate. So we use nitric acid and sulfuric acid. That gets our nitro group meta to the ketone. And now we can add our bromine group in place of the hydrogen that is meta to both the nitro and the ketone, because both of those groups are going to be directing to that same location. Then the last thing that we have to do is to reduce that ketone to the alkyl group, so to replace that oxygen with a pair of hydrogens. And we can either do that with hydrazine and base and heat, or we could use a zinc mercury amalgam and hydrochloric acid. And at our stage, there's no reason to consider why or to worry about which of these reagents would be better, and so you can pick either one. And again, note that in this step, we took advantage of the acylation-reduction combination of reactions for two reasons. We acylated to avoid a carbocation rearrangement, but also so that our carbon chain would initially be a meta director, so that we can get the other groups where we want. Then we reduce that ketone to the alkyl group that we desire.